Welcome to GPT from scratch with MLX with Ray Fernando. So I'm recreating GPT from scratch using MLX, and today's lesson is day 2. And with day 2, we're going to be creating, training, and validation data sets. And this was actually inspired by my friend Ronald Manak here on Twitter. And I actually thought like, hey, this is a good idea to go through this. One of my biggest fears right now is the fact that I may be missing out on this AI trend. And the reason why I would be missing out is because everyone's already like building cool stuff. OpenAI is already happening. Anthropic is here like doing cool stuff with their models. And there's all these startups all over the place just kind of buzzing. And I was like, well, if I used to be an engineer at Apple for 12 years and maybe I'm missing the boat. So I thought, well, this would be a good time for me to kind of take on this challenge and say, okay, let's just start with the fundamentals. Let's just throw out everyone's stuff and everyone's hype and stuff. And like, you know, I can do this with agents. I could do this with whatever. And just saying like, let's just get down to the basics. So this is kind of geared to the busy person as well as myself. And I'll try to keep these to about like 20 to 45 minutes or so. And just kind of chunking down this topic because Andre Kaparthi made a video about this and it's like about multiple hours long and multiple people are doing things. So I'm following the blog from Pranav, and he's also on X as well, and he's basically posted AI Max, and he has this GitHub repo which we're using, and so we're basically on day 2. So we've done we're kind of working on the preparing data, creating the vocabulary phases, which was we done on the previous days. And if you wanted to follow along, just go to rayfernando.ai, and then I actually have a GPT from scratch, and I'm listing all the different episodes, so you can just follow along. That involves getting your integrated development environment set up, like we have here right behind my screen. And then we're going to have, the day 1, which we had the tokenizer stuff that was going. That's about a 20-minute video. And today, we're just going to get into creating and training data validation data sets with our GPT from scratch series. So for today, we're just going to be following along with this part because we've made it to so far. Let me see if I can just kind of move myself a little bit smaller from the screen and make this guy smaller too. Why not? Yeah. Actually, I'm just going to pop you in the corner over here because you really don't need this size stuff. All right, I'm gonna just chill down here. So I'll be chilling down here in the corner, basically. All right, cool. So far, we've taken a look at getting the input, which is basically the Shakespeare all in here, and then we created the vocabulary by getting creating the list, and then figuring out all the stuff that's in there, all the possible letters. And then join them together in this big list. So this is everything that's in every single character that exists in our little text input has been captured in here. And then there's about 65 characters. And then we've created a map for the vocab to integers. So in our main file here, what we've done is created this map for the integer to strings. And then we're basically encoding them, like kind of like chunking down. And then basically it would bring out this thing here. And then we're basically decoding it back. So to kind of better show that, I know I wrote the string twice, but like we can just feed in this list and it should basically say, when I said, it says, hello, Ray, you are great. It spit out this numeric list that basically is represented in this little thing here. So instead of decoding back the string, I should be able to just decode back. I'm going to remove this function here. And let me kind of make this, whoops, let's see, parentheses. All right, so we basically have a print function, and then inside we're just going to put in this array of numbers. And then if we run this thing, it should basically give back the string which says, hello, Ray, you are great. So I'm going to clear this here, clear. Okay, and then just hit the run button. Boom. See, it encodes back to, hello, Ray, you are great. Cool. So yes. So these are the numbers that were up here for the encoding. And then let's just change this first one to like, instead of 46, I'm gonna do 69. And this next one, I'm gonna do 420, just to play around with this, just to understand our encoding. So we should see, instead of hello, Ray, you are great, should be something else. Let's see what happens. Boom, error. Key error 69. So it's possible because I put a number that's higher than that's currently in here, our mapping goes up to 65. I don't know if you remember that for the vocab size. And so because I gave it greater numbers, it's not gonna find it, obviously. So I could just do, instead of 69, I could just do 4, and then instead of 420, I'll just do 20. Boop. And it says ampersand HLLO, Ray, you are great. So I would suggest you kind of playing around with the code as we're going through it. When we were offline, just to make sure you understand like what's really going on and how this like encoding and decoding works. Because, you know, when we did the decode function, we're basically passing these numbers into here to decode them. And like, that's basically what's going on. And it's in the encoding function is kind of doing what this here is. So that's just to make sure you really understand kind of what's going on in this that type of thing here. So that's very, very useful. Let me just go ahead and clear this out. So we're going to go to the next step here where it says we're going to use the enumerate function to iterate over all of the characters and their index in the vocabulary and create a dictionary ITOS, the integer to string, which maps integers to characters, and STOI, which maps strings to integers. Then we'll use these mappings to create our encode and decode functions. Now we can encode the entire text and split the training data. So let's go ahead and do that here. Let's put this down here, and then let's just run it. What do we get? Stuff. Currently, our training data is just a long string of tokens. However, we are trying to train our model to predict the next token given some previous tokens. Therefore, our data set should be comprised of examples where the input is some string of tokens and the label is the correct next token. We need to define a model parameter called context length, which is the maximum number of tokens used to predict the next token. Our training examples will be the length of our context length. Let's look at that first CTX underscore length plus 1 tokens. And so basically what's going on here is that we have to, in order to build our GPT, like the whole goal of this whole thing is to make this model so that when we start giving like this body of text, we're going to basically kind of remove chunks of this text and then start training like our neural network. And our neural network is going to be the thing that we start to give it like information. So it's sort of like predicting the next word and predicting these different pieces. And so part of that exercise is to basically kind of split things down into smaller chunks. And once we have those smaller chunks, we're going to feed it in and kind of like saying, you know, kind of like training. And I think the best way to maybe visualize it is maybe like, imagine you have like, I guess like, let's just see, can I open up like Photoshop or something? Because I think if we're basically removing information. So like if you started to memorize the alphabet, like the only reason why you know it, like if you go A, B, C, D, and if I ask you what the next thing is, you're probably going to say E, right? Because you've heard it over and over again. So imagine removing like A, B, C, and then just removing the middle character. And if I only show you A space C, you're probably going to be like, that's likely the thing in the middle is B. So it's like, you know, because you start to recognize you were given, you know, A and then a blank and then a C together. And because you know that to fill in the blank with B. The only reason you know that is because you've seen it over and over and over again. And we're basically going to make that version like here. And that's kind of what they're saying that we're going to do, is basically how we're going to split this data up and like kind of chunk it out. And so the way that the machine is going to understand it is the technique that we're going to go ahead and go forth with basically. Yeah, I think that's going to be easier than just like popping up in Photoshop and removing pixels to kind of explain this, maybe because that'll be easier for like diffusion models and stuff. So just thought we would do that. So first thing, we did the enumerate thing. So a function to iterate over all the characters in their index in the vocabulary and create a dictionary which maps the integers to characters. So this dictionary here says, let's just go ahead and encode the text. So I want to see what this looks like. So I want to just kind of take this step by step, just so I understand what's going on. So if I just print data, what happens? Run it. Damn. Okay. Okay, we have all of the data. So that this encode takes in all of our vocab. Wow. So it basically have taken the entire body and has just encoded it. And this is the entire work that is in this input file here. And so these are all the numbers that are in the file basically through the encoding. And then we're going to split it like so. So let's just kind of uncomment that code and then just print that. Print, split. Okay, let's just see if it works. This is how you learn. So it looks like it's split its size. Oh, okay. Let me stop the print on the other one because that's probably what's confusing. Okay. Let me clear this out so that you can see clear. And then let me kind of move this to the side. All right. Yeah. Okay. So now if we hit play. Oh, and then, I should probably move my head, my big old head, and just move it over here. That's probably why you can't see it. All right. All right. Cool. All right, so we're just gonna hit play now, and we should have, I'm gonna uncomment these prints up here since we don't really need them either. And they're still gonna, everything's still gonna run. Cool, all right. And then that way we'll clear things out again. And then play. All right, cool. So where else are you printing? Oh, up here. Cool. Let's just play. Okay, now we're good. Okay, clear. All right. So we should basically just see the printout of the split. So this is the split. It's an integer. So it gets the length of all of our data and then times it by 0.9. And so it looks like it's just going to take like 90% of the data there as an integer and then split this. And then we're going to do data.split and then training data. So this is basically how it's going to do the training data. So it looks like we're going to use 90% of the training data. Yeah. And then let's run it. Boop. Okay. Yeah. So this data that we have here, it's just going to split it. Okay. So the data that's in here with those like enumerations looks like we have 90% of the training data that's captured. And then val data is just going to be the split on the other side. And I'm such a noob with Python. So let's just ask it what, okay, whoops. Oh, this auto suggestion. Print val data, please. Okay. Okay. So I'm going to just ask chat. Okay. So what does split, what's the difference between these two is I guess I'm going to ask Python. So I'm just going to remove these prints since they're kind of not really needed. And then this is, what's nice about learning on your own is the fact that you can ask GPT whatever questions you want. I'm here to learn. I'm not here to like pretend I know something. And I think that's kind of, you have to like kill your ego a little bit to to realize that like in order for you to learn, it's your own way of learning. You may know this, I don't know this, and sometimes it's just better to ask, and then you can actually learn a more in-depth answer, I feel. So what is the difference between split and split in here? So then I'm asking Claude Sonnet 3.5 in this model here. And so the IDE that I'm using is Cursor, and Cursor is really great because it allows me to, like do this type of thing, and the integration is awesome. So right now it's doing a web lookup, and hopefully we'll get our answer. All right, cool. The colon before the split is used to slice the data list from the beginning up to, but not including the split index. Okay, this assigns the first 90% of the data to train data. Okay, that makes sense. So it's just going to say there's a split index. And I guess maybe, okay, so this makes a little more sense now. So we first take the text that is from the input, we encode it, which is generating this string of numbers, which what we're doing up here, which, says, hello, Ray is great, and made these numbers, and we changed them, and, yada, yada. We said, let's just take 90% of that, and that's what we generated for our split. And that index is being used now. When it's denoted like this in Python, it's basically splitting, used to slice the data list from the beginning up to, but not including, the split index. And then this assigns the first 90% of the data to train data. This is what we have there. And then the split and then the colon after that is used to slice the data from the split index to the end. So this assigns the remaining 10% data to the validation data. So the whole little function here basically just says, oops, I don't have to add that to the chat. The function basically splits it out this way, and the cleverness up here is kind of defining like where we're splitting the data. And yeah, it's kind of nice to just walk through this with like Python and stuff. And it helps me better understand, the stuff that I'm seeing. Sometimes if I switch between Swift and Python and all these different languages, like I'm doing a lot of Next.js stuff, I always trip up like, hey, there is a specific convention and that's okay. Whatever. That's just the way we learn. So the colon is used for list slicing in Python. So the colon in front means take all the elements from the start of up to the end index. And then the end colon means take all the elements from the index n to the end. So like basically up to that, which makes sense. It's like take all the elements from n to the end. And then the colon in the front means take all the elements to start up to index n. So like, yeah, it doesn't make sense, but I can keep asking. I have to like drill this over time in my head. Yeah, it's okay. It's more different from the Vim split command for splitting windows, which is discussed in some search results. Okay, yeah, cool. Yeah, Vim, all you Vim pros. I think that's going to be my next like series of videos, is like actually giving in and going into like Vim or NeoVim, because right now it's just a little too much to take in. And, I'm still recovering from brain fog / COVID. And this is just my way to record myself and put this out there for the world, but also play it back later on. And so I'm trying to keep these like a little bit short. Usually my energy levels are kind of, can vary depending on what's going on. So I'm going to kind of put myself a little bit down here, maybe just chill. Yeah. All right, cool. There you go. Cool. Awesome. So yeah, if you're following along on the stream right now, if you're live on X, definitely hit the little retweet button so that more people can see this. And what's really nice is that your friends will be able to see it, and other people who will want to nerd out and do something like this, gets just more awareness. And for that basically means that people who aren't following or who aren't subscribed, they'll be able to see that. And so that's super helpful. If you're on YouTube or you're on Twitch, definitely give that thumbs up, give the little like bell icon of the like and stuff like that. That also kind of puts that out there. So definitely appreciate that as we continue forth here. So this is our task, and kind of get rid of that. So now that we this is basically just a way to split the data. Currently, our training data is just a very long string of tokens, which is what we actually saw here in the output. And then let's see. However, we're trying to train our models to predict the next token given some previous tokens. So we're basically saying, kind of like the ABC example I gave. So like if I give you A, B, C, you're probably going to predict that the next one's D, like a very high output. Isn't that cool that we're going to start to actually go through this? All right, so let's go ahead and get this code and put it all up in here. So let's see what it does. So I'm going to go ahead and clear the terminal here. Boop. And then let's just get some beats up in here. I want to make it a little bit epic. Let's go. Shout out to AUDIIO Audio. I have a subscription, and I think it makes it definitely easier to vibe, because that's what we're about to do. We're just going to vibe right now. Let's print this. Let's run it. Okay. How is the text? Should I make it bigger? Should I make it smaller? I'm just curious to see how you're able to view it. I'm trying to, I think I have it like at 4K, but it may be downsampling it depending on where you're watching. Drop any comments and I'll be able to feature them. You are the best. I'm going to say that to myself because I am the best. Why not, right? So what's cool is that whoever drops comments, I just slide you right in and then you just show up. So that's cool. That also goes with people who post on X. So definitely appreciate that. All right, let's get it. All right. Okay, cool. All right, so what we're doing here is that we did context length is 8. And then we're taking the training data and then popping in, remember that split thing that we're talking about? We're doing the context length plus 1. And so the colon in the front means that take all the elements from the start of the index up to n. So we're taking all those elements, which is basically 7 or 7? Yes. Up to the elements. Oh, okay. Plus 1. Okay. And so this is what it generated. It basically got a couple of these. So, it basically took all of this stuff and then just said, okay, let's give you 1, 2, 3, 4, 5, 6, 7, 8, 9. So what it's doing here is that we're getting basically 8 subsamples. And so in the example here, what Andre Kaparthi explains is basically that we have the context length of 8. And then in this example, what it's going to do is like if you have 18, the next likely letter is going to be 47. And then if you have 18 and 47, the next likely combination is going to be 56. And then if you have these two combined and you see them together. So similar to our ABC example, if you have, A, you're already going to think that the next one's going to be B, right? And if you have A and B together, you're probably going to predict that C is next, right? And then same thing, if you see A, B, C, you're probably going to think that D is next. And then if you see the 4, same thing, And so that's basically what we're doing. We're just kind of randomly going through and saying, hey, give me this chunk, give me an extra one. And if I get them these together, I'm going to do this one. And by taking all these samples with all these random numbers, we're taking those numbers are like representation of the text, and we're going to keep grabbing them in, and then we're going to add one to the end of it. And so that way it gets used to seeing what the next one possibly is. And since the context length is 8, if you get 8, that's just a good enough size so that it can, when you start typing in some words and stuff, you can probably predict what the next one is. And you can obviously change that, but that's kind of what he's doing here in the examples. And so if we go back here, cool. So let's read what they say. This is one training example where the input is 18, 47, 56, 57, 58, 115, 47, and the desired output is 58, right? Because we got 8, I think he's doing this. And the desired output is 8 or 58. So that this is 8 tokens of context. And however, let's see. We also want to train the model to predict the next token given the only 7, 6, 5. And then 0 tokens as a context, which is needed during generation. Therefore, we also consider the sub examples packed into this. And so that's basically what he's saying. Not only do you need like 8 to get started, but we should also be able to, if I just give you one, of the tokens, basically like the number 18, you should be able to predict that the next one's going to be 47. In that our ABC example, if I give you A, you should be able to predict the next one's B. And then same, all the way up into 8 letters, basically. And that's kind of why we're doing this little thing here. So notice that the labels are simply the inputs shifted to the left. And so let's go ahead and run this code here. Copy that. Copy that, Roger. Yeah, please don't mind as I talk to myself. All right, let's do this. Let's get this here. Oh, whoa. All right. Then let me make my text bigger. Let's chill. I like to leave my name floating. Why not? A little bit bigger. Cool. Whoa. Yeah, too big. Thank you. I'm just going to leave this like down here in the middle. Why not? Can I group these two? I guess not. Whatever. All right, kids. Okay, run. So the inputs are this, and the labels are here. Okay. So notice the labels are simply the inputs shifted left. Notice the labels are simply, inputs and labels. Okay, yes. So 18, 47, 56, 57. And then if I grab to highlight 47, it's boom. Like everything is shifted to the left. Okay. Where are we going with this? Labels, inputs indexed 1 higher. Okay. It basically has a training data with a context length, and it's just 1 higher. Okay. At 0 index, the input is 18, right? Okay. And the label is 47. Okay. At the index 1, the input is everything before and including the index 1, which is 1847. 1847. So wait. At index 1, which is here, number 47, the input is everything before, which is 18 and 47. Okay, and the label is 56. Oh, okay, so got it. So the way he's saying it works is like, if you have these two combined, you just go down, that's the label. And if you get 18, 47, 56, technically the label would be 57. And if we get 18, 47 like this together, chunked together, the label would be the one that's directly below it and basically repeating down. So this just means that if you have 47 here, that means the next likely number, according to this labeling set, would actually be 58. So let me kind of go that again. So if you have 18, if you look down, that label is actually 47. And then if you have 18 and 47, and if you look down, that number is 56. And if you go 18, 47, 56, and like 57, if you look down, the next one likely to be is 58. So we're just kind of repeating that here. If you have all of these combined, if you look down, that number is 1. And so the thing is like, okay, so what if you have 1847? Like, what is the next number? You know, you have to look down for the label, and then the next one likely is going to be 58 if you combine all of these together. So that's just kind of like a high level of what's going on here. It reads to be very confusing, but I think that's kind of where they're getting here with this. So this is just important for us to know. So at index 0, the input is 18. So index 0, yes, the input is 18, right? And the label is 47, which is kind of what we're talking about. And at index 1, the input is everything before, including index 1, so which is 18 and 47. So yes, so everything before, including index 1, and that's the label is 56. So that's exactly the exercise that we were doing. So now that we understand that the labels are simply the input sequenced together, indexed one higher, we can build our data sets. And so the thinking is like, okay, grab these inputs. Now that we combine them together, we know what the next one is. And that's kind of how the labeling works, is like, we're basically saying, hey, these are the chunks that are together. These are the labels going to be applied. And so creating, training, and validation data sets. Let's get this code and put it in here. And let's just run it. Run it. I'm a big fan of just running this stuff. Okay, so there's no print values, but let's just see what they're saying next. So now we're doing the creating, training, and validation data sets. So let's just see if we can look through before we read this thing, just to understand what's going on. So there's the context length of 8, which is what we got up here, right? Context length of 8. And so we should have like 8 little inputs to the number. So let me just print, oops. Let me just kind of, yeah, print CTX length. Okay, print it. Cool, yeah. So this little 8 is here. Let's see, the CT length GTH is, and then let me put some Python likes these little things right here. Okay, bloop. Let me run it again. So the length is 8, yeah. All right, cool. So we see that down here. All right, yeah. And that length. And then, so what we're doing with context length, it looks like we're passing it into this, like, let me just ask, let's just for fun ask this to our Claude and just see like, what the heck is going on here? Explain this. Yeah. And then, because why not? We have the AI. We have AI telling us things. So why not? Like, I'm not shameful to ask. I think it's really important to use these different systems so that you can understand kind of like what they're doing and what's going on. So yeah, let's just see what the results are. So the code is creating and training and validation data sets for a language model using sliding window approach. Let me break it down. So X train and Y train are being created from trained data. So that's the trained data that we have here. And that's referenced all the way back here from our split. Remember how we did that 90-10 split? Okay. X contains sequences of length, context length from the training data. So that's the 8 digits. We're taking that for the X. And then the Y contains the corresponding targeted sequences. So remember how we're like looking through the little things and we're saying, hey, look down. That's the label. That's the Y. So X is going to be basically the input and Y is going to be the one that it points to. Like, hey, if you have whatever that number is, the next one most likely is going to be that one. And so, which are the same as X train, but shifted one position to the right. Okay, so the X and Y val are created similarly from the value data. So the val data, I think that's mentioned here, is this one that's split here. So that's the split up to, or split and then afterwards. Okay, so the range 0, length data minus context length part means it's creating non-overlapping window size of context length. Okay, so the window sizes that it are grabbing it looks like it's kind of like it's going through chunks of text and making sure that you don't grab any overlapping text for our sampling and stuff. So it's going to just grab this one. It's never going to like overlap with the other one, you know, if it does grab it, because we're only grabbing like 8 of these little tokens type of thing. And so, okay, it means it's creating non-overlapping window size. Okay, so we're getting the length of the data, the range. Okay. And the MX array is likely creating arrays using a machine learning framework, possibly MXNet or something, a similar library. It doesn't know that we're using a MLX core, which is kind of the whole point of this thing, because I have a Mac and, we would be, and MLX is kind of part of this whole thing. So that's kind of why this import's up here. So for those kind of sort of new to Python, at the very top with our imports, we're basically importing MLX core, and then we're naming it MX. And that's our module that we're using. And so this is not really aware that we're doing, it is aware of that we're doing that, but it doesn't really like know much deeper than the name. This approach is common in language modeling tasks where you want to predict the next token given a sequence of previous tokens. The heck, what's going on here is essentially preparing the data. Yo, this is great. The heck what's going on here is essentially preparing the data for a sequence prediction task where each input sequence X is paired with its corresponding target for training, which is Y. It's worth noting that this approach assumes that data can be evenly divided into chunks of context length. If that's not the case, some data at the end may be discarded. To avoid this, you might want to consider using overlapping windows or padding the last chunk if needed. So yeah, that's just kind of what's going on here. So we're at the creating, training, and validation data sets phase. We have basically just copied this code and we're trying to figure out what the heck is going on here. This is like some fancy, one-line stuff, which is cool if you know what's going on. And so that's kind of what's going on here. So that is what it is. All right, so we loop through the data and take chunks of context length as the inputs X, and then take the same chunks but at one higher index as labels Y. Then we take these Python lists and create MLX array objects from them. Aha, so that's kind of what we're seeing here. So the MLX array objects are the ones that are being created. Since we're using the MLX framework, that's kind of what we're doing here. And the reason why we're using this is because I don't have a GPU. And so I don't have like an NVIDIA thing or a PC. I'm using a Mac. And I thought, okay, well, there is this framework that's already been created called MLX that's using the Python stuff. And so that's kind of why we're arriving to this. And this may look a little bit different than Andre Kaparthi's video with, doing GPTs and the way he's doing it. So, and that's why we're using Pravnav's thing, because he's already done this and it's just kind of cool to follow along. All right, so let's see. We loop through, we create the context looks at the input X and then take some of the chunks labels Y. We take these lists, create MLX objects arrays from them. And the model internals will be written with MLX. So we want our inputs to be MLX arrays. Right. That's why this is MX dot arrays here. And that's basically assigned to X train, Y train, and then X val and Y val as well. So that's there. So one more thing, during training, we don't want to feed the model one example at a time. We want to feed it multiple examples in parallel for efficiency. This group of examples is called our batch. Okay, so if we feed the examples one at a time, it would take quite a bit of time and may not be a good use of resources. And since these machines are very powerful, we can just kind of batch them together. It looks like we could probably do groups of 4 or something like that. That's probably what they're going to do. And so this group of examples is called our batch, and the number of examples in a group is called the batch size. So thus we define a function to generate batches for training. So this is this function here, and then let's put that there. Cool. So this is the definition for get batches, and so we have the inputs, which are going to be X, Y, the batch size, and then to shuffle, true or not. So if we're shuffling, this is going to be how it shuffles its thing here. Random shuffle with X and Y, and then this little thing. So it yields the input and the label. Okay, great. If shuffle is true, we shuffle the data by indexing it with a randomly shuffled index. Then we loop through our data set and return batch size chunks from the input and label data sets. These chunks are known as mini batches and are just stacked examples that we process in parallel. These mini batches will be our input into the model during training. Here's an example of a mini batch of 4 examples with context length 8. Okay, so a mini batch is this. And so we have our inputs here and our batch sizes are basically each row. Okay, so yeah, just to kind of drive the point home, and these are the labels of the mini batch as well. Okay, so in this thing, if we kind of look, I'm gonna move my head over here and kind of make it a little more serious. So if we look at this label here, basically, 18, 47, 56, like this stuff here is this one row, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the context length of 8. And then that's one batch, 2, 3, 4. Like this batch size, would be 4. And then the labels would be here at the bottom. And the way that this works is like 18, if you were to predict what the next one's going to be, if you look down here at the label, that's going to be 47. And then remember how we were talking about 18 and 47 combined? If you were to figure out what the next one is going to be, you'd have to look at that first row, which would be 56 down here. And then there's 56. So 18, 47, and 56. If you get those three combined, remember how I was telling you A, B, C, and then guess what the next one is going to be? D, right? So what does that look like? If we have 18, 47, and 56, we have to go down. That's 57. So this is basically a way to parallelize things. So I guess you would just kind of imagine like these other ones don't exist. Let me see if I can make a little square so they can, whoops. Yo, the square is so massive. Like, can I make this? Yeah, okay, let's bring this down. Chill, bro, chill. Okay, here we go. Now I could probably show you with like moving things. Okay. So this is the input. And then, oh, can I get let me just duplicate this. Yo, okay, cool. So we have 18. And then if we have 1847, guess what you're gonna look at? This guy down here, 56, right? Like 1847. Let's duplicate this, why not? Oh, let's go. Yeah, this is way better. Okay, cool. And then if you have, let me duplicate this too. This is probably a better way to show this. Yeah. Okay, cool. Yeah, all right. So you have 18, 47, 56. You look down, that's that one. And then if we have this next batch size, we're just gonna move this over and we're gonna move this over. So 18, 47, 56, 57, the next one's gonna be 58 according to the label set down here, which I should probably make this available. Labels, input, all right. And then same with here, I'm just kind of walking through this by hand so I sort of can understand what the code will be doing and what we'll be doing, kind of learning together. And so that's that. And so you're like, okay, so that's the first one. So what happens to the next one? Since these computers are very smart and can process things in like parallel, it's going to do like all 4 of those basically at the same time in its computation because the machines are waiting for input. They can take multiple threads at the same time. And the best way to think about this is kind of like a stovetop. If you have 4 burners and you're only using one, it would just be kind of a waste to not use the other 3. So like, or, so that you're using all 4 at the same time. That's basically what we're doing here. We're cooking. We're like literally cooking with language models. So the other like burners would be that one. So like, at the same time, let me duplicate this guy just so that you have an example, you have a heads up of what we're doing here. So we go back to this sample. So we're in row 2 now, right? So row 2, I'm just gonna show that there. And then over here, we're gonna cover this guy up a little bit because we don't care about these ones. And then we're looking at row 2. So I'm gonna cover up this one. Whoops. Row, yeah, there we go. That way it's kind of covered. All right, so now we're looking at row 2, and then let me duplicate this just to hide this rest of the stuff. So if we're looking at the first input, the label shows that the next one likely is 47. And then if we kind of move this to the right, which I do here, somehow, yeah, 47. So if we have 47, the next label that, if we have 58 and 47 next to each other, the next one likely is going to be 64. Yeah, down there. And then if we move this one over here, 64, 58, 47, 64, the next one likely is going to be 43. So basically kind of ignoring the first 2 there. So I don't know if that makes any sense. If you're picking up what I'm putting down, definitely give like a thumbs up, give a like, make a comment, because this can get confusing, but I feel like I'm trying to demystify some of this stuff. This stuff is can be a little thick to take in, but that's basically kind of what's going on here. I think of a batch size as like if you're thinking about a stovetop, one of the burners on the stovetop. And so if you have 4 burners available on your stovetop, you'd want all of them to be used. So then we can just pass in, 4 batches, right? So like, each stove can do the calculations and the predictions here. So that's kind of the example for the mini batch. So this mini batch packs 32 next token prediction problems. So the way they get 32 is 8 times 4, 8, 16, 24. Wait, 8 times 4. My math is all backwards. Yeah. Right? Yeah, 8 times 4 is 32. Yes. 8, 16, double 16 is 32. Yep. So if you add all of these up, so you have 8, 16, and 32, right? So like that's basically what we have. So the model will predict the next token for each token in the input, and the labels will be used to calculate the loss. Notice that the labels contain the next token for each index of the inputs. So that's kind of a fancy way of showing you the way that I was just explaining it, is that like whenever you're moving through each section, that's called the index. So that means, 0, 1, 2, that's the index. And when we went down to the label, that's, the prediction there. So that's kind of what we were saying. So you want to keep this picture in your mind because the shapes of these tensors will get hairy. So for now, just remember that we will input a tensor of shape, batch size, and context length into the model. So the batch size basically means this. Think burners, each of the little burners on the stove. So we have 4. And then context length was like how much, how many ingredients are going to put into that pot and into the burner, right? So like that's, I guess, the best way to analogize this, because like we can cook. So, right. So I think this is probably a good stopping point for us on the GPT from scratch, and kind of to talk about a little bit about what we've covered so far, because I feel like this is probably a really good, because I'm doing this for multiple days, and it's just good to kind of stop and kind of think about what you've been learning. I'm usually a big fan of speed runs, but this stuff is a little thick, and on this learning journey, I feel like this kind of needs to take its time, and you kind of have to really digest what's going on here, because these people have spent like a decade plus learning this stuff, and not to mention the university experience, but also in real life, to then pass it on to us. And for me, because I want to take this seriously as an engineer, I really truly want to understand how this stuff works, and that means by playing or solving some examples. And so I'm going to be chunking this down to like the smaller sections, and this will take a little bit longer to learn, but I feel like it could be more digestible for me, and it may work for you, may not. And if you're like, I don't care, I just want to just full throttle, turn on the cheat code, by all means, please do that. Watch Andre Kaparthi's videos. But this is going to be a little bit like somewhat slower pace, but it's more to make sure that we understand what's really happening in this space, and because like this is going to be super important. This is like the future of what's happening, and the clearer that we can understand how like this tokenizing process works, how we get data, how it gets labeled, how it gets put in these systems, the better that you can speak to the future generation of changes, or the more insights you'll get into like where problems can occur, And so that's kind of what Andre Kaparthi explains about the tokenizer, how like that was the kind of thorn in their heel. They have this great model, this great stuff that's going on, but the tokenizer was the problem. And then by improving that with GPT-4, they got phenomenal performance, from the same code that they were seeing with Python, right? So like that's an interesting insight that he shared that I found extremely useful. And another reason to kind of really take these things and use as many resources as you possibly can to try to digest this. So let's just kind of go back a little bit of what we were talking about for today, and then kind of wrap this up so that tomorrow we'll be getting into coding GPT-2. And so that'll be looking at the architecture and seeing what we're trying to actually implement. And so we're going to be implementing this with MLX as explained here. So it's important here that we basically, from the beginning, is we've got our pre-training data stuff set up, which is like making sure we have the text training data set. And that's kind of what we see here with our input. And then we created the vocabulary, which is kind of getting the vocab size with like the inputs, and then basically telling the computer like, hey, these are every single character that exists in this length here, and creating like an encoder and a decoder type of thing. And so we map the basically integers into strings and strings back into integers. And then from here, this is where we did like our splitting of the data set. So we're taking 90% of the data and putting it into the area that we'll do the training for. And then we're going to take the other 10% and we kind of put that to the side. That's going to be the way that we validate to make sure that when I say, worthy, whatever this word is, in the text, that the next thing is going to predict is a semicolon, and then this, all this other stuff that kind of follows after that. So currently, the trading is just a long string of tokens, which is kind of what we were going through here. We learned about context length. So the context length is basically, the 8 slots that we have there that's available, and then basically print the training data +1 so that we can understand what the next one is. And then we went through this fancy exercise of understanding if, like in the alphabet, you have A and B, the next likely one's going to be C. And if you have, 8 versions, A, B, C, D, E, and then the next likely one's going to be F and so forth. So, and if you have them all combined together, that's how you know that the next one's going to be G and so forth. So like that was basically what we were doing here, and kind of getting that set up. And then the next thing we did was creating the training and validation data sets using MLX. So with MLX, we did the mx.array, and that was kind of labeled through there. And we were also using some of the chat to basically go over like understanding like what the heck is going on here, which is kind of right behind me, basically, as you can see. Let me see if I can turn off my camera. So that's kind of what we're seeing there. And so then once we did that, during training, we basically made a little batch thing. So this is getting the batches to create these little batch sizes. And that's basically the exercise here. It's like, of all that training data, since we have a computer that can go burr, let's take full advantage of that and just giving it, instead of just using one out of your 4 places on the burners on the stove, we want to use all 4 so that the computer stays busy and we're able to crunch these things. And that's kind of the advantage of, the hardware that we have. And so that's kind of where we are at right now. And if you've been following along, I definitely would recommend to check out rayfernando.ai. And on my website, you're going to have the GPT from scratch at the top. And then you're going to have today's thing, day 2. I have basically every day kind of listed out here. And so if you just click the first one, for example, I'm going to have the episodes basically listed out. So today we're basically creating training and data validation sets. And then in here, you'll see the actual live stream video, so you can rewatch it as well. And then I'm going to try to maybe put my own thoughts and notes, kind of trying to explain some of the stuff that we did there. And here's some references as well from Andre Kaparthi. So if you want to actually see the video, he says, let's build GPT from scratch, you can click that. And this basically shows you what he's talking about there and how he's doing that using the Python library and stuff like that. And he's using Torch, the torch.nn. So that's a little bit different because we're using MLX, and I have an Apple computer, and that's kind of why we're doing the MLX version of creating GPT. So I thought this is a good way to kind of get us here so far and kind of land the plane a little bit. So if you're following along, definitely recommend to check me out on Twitter if you haven't been following me there. So at rayfernando1337. And I'll be posting more updates. Definitely hit the little bell icon. If you're on YouTube, definitely feel free to check me out on YouTube. I'm just at youtube.com/ you have to put the @ symbol, rayfernando1337, and that'll be me here. And basically, you'll see my live streams posted. And this is kind of all of the live streams and have some interviews and stuff. So if you haven't had a chance to, definitely hit the subscribe there as well. And on my website at Ray Fernando, at the very top, you can actually enter your email there. And that's where you'll be able to sign up and get updates and so forth. And so let's stay connected, because I'm just going to keep doing this. My goal is to keep, to build the GPT from scratch every day. So work on this daily. This is actually my goal. Live stream as much as possible and post update to my blog. So that's basically my goal. And my goal is to learn how this stuff works so that I can train my models and understand every little parameter that's going in and how to make further efficiencies. I used to be an engineer at Apple for 12 years, and basically I got COVID in 2020, and then basically had brain inflammation. A lot of joints get swollen and inflamed, and I couldn't do anything. I had so much brain fog, fatigue, and I even had severe memory loss. And so since then, I've now recovered, and I'm healthy enough to do work. but the Apple had actually let me go, which is kind of a pain in the butt. So I actually made a video and I posted it to my YouTube channel, a little bit about describing kind of like the high level overview. But yeah, I was let go and now kind of doing stuff on my own. And I really want to learn AI. And this is just a way for me to kind of chunk things down into digestible bits and share with you on my live stream and connect with me. So feel free to DM me, send me a DM if you want to connect and kind of hang out. Going to be working on this, and I really do want to work on this because I feel like learning this skill is just going to help me improve my engineering skills. This is currently what's happening right now in the world, and there's so many opportunities that are going to be branching out in the coming decade for all the stuff that will be, you know, referenced from these papers, from these exercises, and everything is kind of built on each other. So I feel like, you know, I'm not behind. It feels like I'm behind right now, even though stuff, you know, this GPT-2 came out like in 2017 or 2016. I forget what it is, 2018, 19. Oh, actually 2019, was it? 2019. Yeah, 2019. GPT-2 came out in 2019. I feel like old already. It's like, oh my God, this has been with us for long. But like, there have been many breakthroughs and a lot of stuff to learn. And this is a good place to start because it's actually doable on our machines. We don't need like these crazy supercomputers and stuff. So I appreciate you following along, and I'll see you tomorrow. Thank you. Peace.